project that aims to bring orchestration, high availability, and also scaling to OpenStack. So first, I'm going to spend about 15 minutes talking about Heap in general, what it is, what it does, how would you go about using it, that's why. Then I'm going to give you about a 7-minute long demo, and at the end, and if there's time at the end, I'm going to try to answer some questions. So what is Heap? It's a fairly recent project built internally at Red Hat, but it sort of aims to be a proper OpenStack project. I'm going to get to that later on. And it aims to bring orchestration, high availability, and auto scaling to OpenStack. So what that means is when you want to launch something that is a bit more complex than just launching a single VM, there you can just SSH into it, install the packages, and be done with it. But if it's something more complicated, for instance, you have a database server to which there are connected 3 application servers, and you want to have a load balancer in front of that, and perhaps putting IP addresses on EBS storages and quantum networks and stuff like that. Suddenly it becomes a bit more complicated, and you actually want to have some sort of script that will, bring it all up and keep it there. So that's essentially what Heap does. The way it works is you write what we call a template, where you, using a declarative language, you essentially describe the cloud deployment that you want to have. So you would put that you want to have these sort of databases that are backed by EBS, that you want to have these application servers with a load balancer in front of that, and all that. You describe that in a file, you put that file to Heap, and it will process it and launch the thing, make sure that all the dependencies are resolved and that all the instances are provisioned. And at the end, optionally, you can have Heap to keep it up and monitor it. So Heap in and of itself doesn't do much. It needs to be connected to the OpenStack services that actually do the proper work, right? So you're going to have, you're able to connect to Nova and launch Nova instances. You're able to attach block or Swift storage. You can use floating IP addresses, load balancing, auto scaling. Those two are not natively supported for OpenStack, so Heap does that. And we have support for networking via Quantum. Now, in case you're familiar with Amazon CloudFormation, Heap has been inspired by that very heavily. So from the beginning, we aimed to create the same API in the same template format, which allows the existing customers of CloudFormation to move into Heap. And one good side benefit of that is that Heap can be accessed by Boto, which, if you're familiar with that, that's a Python library that is used to that talks to all the different Amazon AWS APIs. As far as Heap versus OpenStack goes, along with Ceilometer, Heap is the first external project that has been accepted to the OpenStack incubation process, and we're using the same infrastructure. So our code is on GitHub under the OpenStack organization. We use review.openstack.org for code reviews, and we use the same launchpad, OpenStack Wiki, etc. And we try to follow the same code style and architecture. So ideally, any experienced OpenStack developer should feel reasonably comfortable with the Heap code base and the processes that go into that. Now, I'm going to show you a sort of quick example of what writing a template for Heap looks like. I don't want to get much into the details because it doesn't work very well on the slides. But so the basic structure is as follows: you have a version declaration, you have a description which can be shown in the UI, and then you have 3 main sections: parameters, resources, and outputs. Parameters are for user-specified parameters that you want to enter when you're launching the template. So these would be things you don't want to have hard-coded or can't have hard-coded, such as the Nova SSH key panning that you're going to use to SSH into an instance, or if you want to have, for instance, the Nova flavors parameterized so that you can use the same template, and for smaller or larger instances, you can put that to the parameters and then reference that. Resources sort of are the main section. There you actually describe all the actual OpenStack resources that are going to be created. So this is where you would put all the declaration of your virtual machines, your databases, your quantum networks, subnets, floating IPs, and all the associations that you need. And then lastly, outputs. Those are for sort of user-defined information that you want to get back once the whole thing has been launched. So if what you're launching is a web app or an API, this could give you back the public entry point, which you might not know in advance if it's an API / something, or it might be the internal APIs of all the instances that you launched. And that is, again, configurable. So essentially anything that's in the open section, it can be referenced. You can put like any resource that you've defined earlier on. You can put information from that resource there. So things such as IP addresses that you don't know in advance. Here's an example of an over instance. Each instance has each resource has a type. So here you can see this is sort of remnant of the CloudFormation. We're going to change that a bit, but we still want to maintain the backwards compatibility. And you can specify a couple of metadata. So image ID would be a client's name of the image that you want to launch from. Instance type is essentially OpenStack's flavor, and key name is the SSH keypad. And you see that here we're not using absolute values, but a reference. And the thing that we're referencing is actually the parameter that the user is going to pass when we launch this. And the last two sort of important sections, for instances, are metadata and user data, where essentially you can put all your provisioning code. So in the metadata section, you can put packages, services, and files that you'd like to have on the instance when it's launched. So if you want to have Apache or MySQL there, you would just list it there. You can specify exact versions or just leave that blank, and then it is going to do what the best it can. You can specify the services that you want to have running or not running. And you can specify files that you want to have there. And once that heat is then going to make sure that all that is on the instance in the state that you want it. And then any custom code, any custom shell script that you want to run is going to be put in the user data section. So you can just do all your final configuration there, or if you want, you can use Puppet or Chef or whatever else. He just sort of agnostic in that way. And the last thing before the demo, I'm going to talk a bit about CloudWatch, which is, again, that's originally an Amazon services. We ported that for Heat, and that's a service that monitors the resources. It monitors the virtual instances and their resources, so you can monitor things such as CPU utilization, RAM consumption, hardware consumption, and you can specify custom triggers that are going to be that will run your own code if you want. So, for instance, when you go over with memory, you can specify that Heat is supposed to launch a new instance or whatever else, and that's actually what I'm going to show you in the demo. So what I'm going to do is have Heat launch a WordPress instance that's in front of a load balancer. Then I'm going to simulate a load that will take the memory to the high level, and we'll see that Heat is going to spin up an instance automatically, and then when the load decreases, the extraneous instance is going to be shut down again. So before I get to that, I just want to show you, doesn't look very well, but just a brief sort of choice sections of the template that I'm going to be launching. I try to. This is the section where you can specify files. Is that better? Yeah. So this would be a file that you want to have included that defines the MySQL configuration. and all the references there would be database name and username and passwords that the user would specify when they launch the instance. A bit below, we have a list of packages that we want to have installed and a list of services that we want to have running. And just one last thing, I'm going to show you how the auto-scaling thing works out. So you can specify an alarm. This alarm is called mem alarm high, and what it does is on just when you have memory higher than 50%, it will spin up another instance. Here we go. So here we have the metric name is what we want to watch, which is memory utilization. Threshold would be the threshold that we need to cross. So when this threshold gets crossed, we're gonna call up this web server scale policy, which is defined a bit above, and that just spins up another instance. And we have the same thing essentially for the for scaling down. Now I need to do a live demo, but the problem is that there's lots of waiting around when you spin up an instance and turn it down and all that. So I recorded a screencast. I'm going to show you that because then we can skip the boring bits, and later on, if you're interested, I can show you how it works on the real laptop. So what I'm going to do first is doesn't look very good, sorry about that. So this just lists the Nova instances. This is Nova list and heap list commands that show that we don't have any instances there running. So now we're going to essentially run the template that I just showed you and wait for it to come up. So this is now creating progress. The instance is being created, which is going to take some time, so I'm just going to skip. And now we see that the load balancer and the WordPress instance are running. I'm going to SSH into the instance and tail the heap provision log, which is a log file that is going to show you all the provisioning that's happening on the instance. So installing all the services, packages, adding the files, and running configuration. And now that that's done, I'm just going to show you that we can actually look at the instance and spin up and show the WordPress setup. Yep, all right. So once that's done, we're going to use the usable stress command to simulate memory load. This is going to make sure that the memory gets well over 50%, so that should trigger the autoscaling. Now there's more waiting around. After about a minute or a couple of seconds, you can see that the memory that they received in the log, that the memory of the instance is too high, so that it's going to trigger another instance, which we're now going to show. It's not easy to see, but in this section, which is when we started, we had two instances, and now we have the same instances here, and another one below that, which has just been spun up, and it's in the build state now. So we wait for the build to finish, and just sorry about the echo, and just look it up to see that it's running as well. And now, last thing that we're going to do is kill the stress and kill the load and wait for the instance to get deleted again, which is ideally what you see now. Now there are only two instances, the two original instances that were launched. So that's it for the demo, and I have one last point to make. Heap is a fairly young project. It started in March 2012, so it's not even a year old. It's had about 5 contributors throughout the time, All of those are from Red Hat, but we want this to be a proper OpenStack project, so if anyone is interested, we're very much welcome contributions. We've had about 12 other contributions over time, some of them outside of Red Hat. These were people who were actually trying to use heat in their own infrastructure. So we've had some real use cases and real feature requests and bug reports, so it was not developed in a vacuum. And sort of the last point that I'd just like to mention is for the metric system in CloudWatch, which I've mentioned earlier, some of our coders are collaborating with Ceilometer, which you're going to hear about later on, for gathering the metrics from directly from the hypervisor from OpenStack. And that's it. If you're interested, you can go to heat.api.org or go to GitHub for our code. We're on Heat on Freenode. The team is distributed. We have people in the US, in Europe, and in Australia. So you have a pretty safe bet that someone's going to be there at any time throughout the day. And yep, that's about it. So do you have any questions? Yeah, go ahead.
Do you need Ceilometer running for the auto-scaling stuff?
No, the question was whether we need Ceilometer running for the auto-scaling. We don't. For the moment, the demo that I showed you did not use Ceilometer. You can use your own monitoring systems that are running from inside the instance if you want, and just post the data. So you can use that. Any other question?
Will it be ready for Grizzly, or is that too early?
Yeah, I'm not entirely sure. I know that it's, I don't know about the packaging itself. It's working with Grizzly, and you can use it in DevStack if you want, but I don't know how the official release thing is going to go on, because it's not a part of the whole project yet, and we don't know what, it's not clear right now for what OpenStack code really means or what it's going to mean in the future. So we're going to wait and see. Right now it's in incubation. Yeah. Anything else?
Do you want to support more cloud providers?
Yeah, we had some interest from someone from CloudStack actually about writing a backend so that he could, do his thing, but instead of talking to OpenStack, we talk to CloudStack. And I myself wrote a patch for adding support for Delta files. So right now in Heat you can write your own plugin and use and write sort of code that would bridge Heat to different cloud providers other than OpenStack. Yeah. For image configuration, he doesn't do that. He sort of launches images, but after the image is launched, you can run any code you want. So if you want to use Puppet, you could just put the Puppet script into the template and then the invocation as well. Right? Yeah.
How do you measure metrics?
Right. So, what I showed you in the demo is essentially we have an agent running inside the VM. It was just a simple cron job. The demo that I showed you is on our code, on our GitHub repo, so you can just try it out yourself. So we try to make things easy. So it was just a cron job that every minute read the metrics from within the instance and send them to CloudWatch. But you can use your own metric system, or you can use later on Ceilometer, which essentially is going to read the metrics from OpenStack itself, because KVM does know the metrics, at least CPU utilization, stuff like that, the whole of the metrics, but these particular that.